Let's go over 4.2, section 4.2, example 3, trig functions of a 30-degree angle. Okay, we're going to start with a right triangle. Where I have a 30-degree angle, a 60-degree angle, and my 90-degree angle. Okay, my 30-degree angle is across from the shorter side, the 60-degree angle is across from the longer, and the 90 is across from our hypotenuse. Okay, let's start and let's say that my hypotenuse is 1. The length of my hypotenuse is 1. If you remember from 30, 60, 90 triangles, if I know my hypotenuse, my side across from my 30-degree angle, the shorter side, is half the length of that. So my side over here, the shorter side, is 1/2. Now I can use the Pythagorean theorem to find the remaining side. So I know that 1 squared will be equal to 1/2 squared, and we'll call this x, plus x squared. Okay? So 1 squared is 1. 1/2 squared would be, you have to square top and bottom, so it would be 1/4. So I'd have 1 subtract 1/4. And that would be equal to x squared. 1 subtract 1/4. If I change this to 4/4, because 1 is the same thing as 4/4, I would end up with 3/4 equals x squared. And then I would need to find the square root of 3/4. Okay? So I end up with x equaling the square root of 3 over 2. So my x is the square root of 3 over 2. Okay, so now that we know this, let's write our trig functions, our 6 trig functions for the 30-degree angle. Okay, so we're going to start with sine. Sine of 30 is going to give us opposite over hypotenuse, so it's 1/2 over 1, or just 1/2. Okay, then we do cosine of a 30-degree angle, and that would give us adjacent, which is your square root of 3 over 2, switch that over a little, over 1, or just the square root of 3 over 2. Okay, our tangent of 30 degrees is going to be opposite over adjacent. So we would have a compound fraction here, 1/2 over the square root of 3 over 2. Okay, so if I multiply by the reciprocal here, my 2's will cancel out, and this would actually equal the square root of 3. Okay, now we're going to go to the other ones. Our cosecant of 30 degrees is going to be equal to the reciprocal of sine, so it would be 2 over 1. Our secant of 30 would be equal to the reciprocal of our cosine, so we would end up with 2 over the square root of 3, but we need to rationalize the denominator. And so that gives us, squish this up some, that gives us 2 square roots of 3 over 3. And for cotangent of 30 degrees, we would have the reciprocal of the square root of 3, so it would be 1 over the square root of 3, and rationalizing the denominator, we get the square root of 3 over 3. Okay, those are your 6 for the 6 trig functions of a 30-degree angle. Okay, now let's talk about using these to find, or using one trig ratio to find them all. So this is example 3, and this is 4.2, example 3. Oh, The other one must have been example 2. This is example 3. Okay, and it's, suppose we have sine of an angle theta is equal to 5/6. Okay, so if I draw my triangle, let's say this top is theta. I don't know what the degree of the angle is. It doesn't matter at this point. But I do know that sine is opposite over hypotenuse. So my side opposite theta would be 5, and our hypotenuse is 6. Now, if I use the Pythagorean theorem, I can find the other side of my triangle. So I would have 6 squared is equal to 5 squared, and we'll call this x for now, plus x squared. Okay, so if I solve for x, I would have 6 squared, subtract 5 squared equals x squared, which gives us, this is 11, equals x squared. If I square root that, my x is the square root of 11. So my missing side here is the square root of 11. So now I want to write all 6 of the, well, we already have sine. I want to write the others, knowing that, knowing my 3 sides of the triangle, I can write all of the others. Okay, so let's do cosine of theta. Cosine of theta would be my adjacent over my hypotenuse, so I'd have the square root of 11 over 6. Okay, tangent of theta is going to be opposite over adjacent, so it'd be 5 over the square root of 11. So it ends up being, after I simplify, 5 square roots of 11 over 11. Okay, then we go on to cosecant. That's going to be the reciprocal of my sine, so that's simply 6 over 5. My secant is going to be the reciprocal of cosine, so it'd be 6 over the square root of 11. Simplify that, and you end up with 6 square roots of 11 over 11. And cotangent is going to be the reciprocal of tangent, which originally I had 5 over the square root of 11, so it would be the square root of 11 over 5.